Hi students, from today onwards, I will tell you another important issue related to our wireless communication, and that is mobile IP. Mobile IP, IP means Internet Protocol. This can serve the uh, needs of bargaining population of mobile computer users who wish to connect to the internet, and they can maintain the communication when they can move from its own home place. This mobile IP is uh, an internet engineering task force standard communications protocol, which is known as IETF. In short, it is known as IETF. That is designed to allow mobile device users to move from one network to another network while maintaining a permanent IP address. That means an IP address that cannot be changed, but I can move from one location to other location. This enables the transfer of information to and from mobile computers such as laptops and wireless communications. The mobile computer can change its location to a foreign network. You may ask me, sir, what is foreign network? Actually, in case of mobile IP, when I will describe everything in terms of its network architecture, I will tell you there are two networks. One is home network, where the mobile device actually present. Another one, when a device that can move from one location to other location, then the device uh, may be present under another access point or another different network architecture. I mean to say, in terms of its IP address. Then this uh, new network where it is now visited, that is known as visitor network, or better to say, actually it is known as not like visitor location register like our GSM. It is known as foreign network. Okay, where it is now moved from home network to new network, that is foreign network. Um, so this is foreign network, and you must remember when it can move from home network to foreign network, still access and communication, both of them is possible like previous way. Everything is same, but the propagation through the IP address, that is different, and that we need to study over here. Mobile IP, this is a technology which can support mobile data or and applications. Those are dealing with wireless connectivity actually. Um, and that connectivity may be established through one address which is known as IP address. The user may now disconnect from his computer in the office and reconnect to another site within the same office or elsewhere. This is possible only when I want to use mobile IP technology. Okay, and mobile IP, it is actually defined by IETF, Internet Engineering Task Force, and those design issues related to our mobile IP that can be defined by IETF, that task force. So everything is standardized, everything is defined through certain benchmark of the system. Now, when I'm talking about mobile IP, the enhancement of internet protocol, then it allows a node to change its point of attachment to the internet without a requirement, without any requirement of change its IP address. Mobile IP is independent of the physical layer technology, as the mobility functions are performed at the network layer. Any media that can support IP and can support your mobile IP. So this is mobile IP. First of all, everything it is very common to us. Protocol means a set of rules. A protocol is a convention. It is something related to standards that controls or enables the connectivity, connections, communication way, and data transfer between two computing endpoints. In its simplest form, a protocol can be defined as the set of rules governing the syntax, what kind of language, what kind of particular text may be used. Everything can be governed by these particular rules, and that rule is known as our protocol. Something semantics that is also controlled by protocol. Synchronization, another issue that is also controlled by protocol. So this is protocol. And when I want to tell you this mobile IP, then next issue, what is the goal of the network layer? The main goal of the network layer to design the right way of the routing protocols. How to obtain the routing path, that is the main issue of discussion related to network layer. Why? Then my answer is very straightforward. This network layer associated with routing techniques, and this is something related to next to that decrease routing related overhead. This is under the routing protocol objective. But what is the meaning of this term, routing related overhead? Routing related information that may contain anything, means what are the information may be there. Something related to routing paths, what kind of particular information packet may be transmitted, what type of protocol it is used. Everything is related to information. When the routing information is more, then it's quite tedious for any path or any routing protocol to handle the situation very easily. Why? Because if the information is more, then the main data, if I want to write or draw one frame structure, you must know one part is related to address and some usual information of synchronization. Another one is related to the original data. If the other informations than your data is more, then it is quite critical, because the system requirement in terms of its capacity, that requirement is more, because I want to transmit a packet over a certain path, and that routing path can able to carry certain packet. If the packet information is more, then it's not possible to uh, pass all those information very easily. So we need to think about that information, how many bits should be used. So what we need? We need to use useful information. What I need actually, those bits should be used, those informations should be used. Other than that, it is totally overhead. So I need to minimize all those overheads. This is the primary criteria for any routing protocols. The shortest path. We need to find the shortest path. What is the benefit? If a signal that may be propagated. I want to show you one thing. Just see what I want to show you. I want to show just simple architecture related to our ad hoc network. In case of ad hoc network, you know what we need: a simple one source and one destination. If I have one source and one destination, then it is very easy to propagate one information from source to destination end. But you must remember there have multiple nodes in between source to destination. When I want to think about it, then we have those nodes association is most important. Why? And why should I consider ad hoc network? Better I need to consider infrastructure-based network. If I want to think about infrastructure-based network, then also it is most important, because in case of infrastructure-based network, the issue is the propagation, and one source node is connected with another destination node via some middlemost intermediate node. If it is true, then you must remember the issue of this particular destination node and the intermediate node, something like this. I want to show you, this is your source and this is your destination, and in between intermediate node is there I, and there have one IP address, and IP address. That means infrastructure based network, not ad hoc network. Okay, not ad hoc network. No more ad hoc network, simply infrastructure based network. If it is infrastructure based network, source node wants to transmit its information towards intermediate node. Because of the longest distance, it's not possible to transmit directly towards destination. So it may take the help from this intermediate node. And this intermediate node may transmit the information towards destination. Okay, so intermediate node is something like one node which can help the transmission between source to destination, which can act like cooperative node. So no problem over that, but one thing is most important. If the reliability, that means I am talking about this path, if the reliability of this path is lost, that means this path may not be connected due to some problem, then it is not possible to transmit the information from source end to destination end. That means it is quite important to think about the path. And the path, if the path is very reliable path, then no more packet drop. If the path is unreliable or non-reliable, then it is quite possible that some information or some packet may be lost. If the packets may be lost, then what? Then again I need to transmit the information, but I need to find another intermediate node. That means first I need to find the route, and through that route again I want to transmit the information. It will create more cost, and path cost may be enhanced. Then another thing may be found that the information may be corrupted, and ultimately that information is received at the destination end, and destination is getting completely wrong information from the source end. Okay, so this is the most important thing for this uh, path oriented issue. Okay, so you need to think about that path oriented issue. Next to that, another important issue related to stable routes. So why should I consider these stable routes? Because if I want to think about mobility, then if the route is not stable in terms of its reliability, then also another problem may be happened. That's why we need to think about the routes with more stability or higher stability. So these are the important goal of the routing protocols. When I want to think about the goal of mobile IP, then what is the main objective? Supporting end system or terminal systems, those who can have some mobility while maintaining scalability and efficiency and compatibility in all respects with existing systems, because scalability is the most important thing. Another important issue I want to tell you, robustness of the system, it is the most important thing for any wireless communication. Now, mobile IP, already I told you it is proposed by IETF. Using mobile IP, nodes may change their point of attachment to the internet without changing their IP address. That means the IP address that is fixed, but the node can move from one location to other location. Okay, mobile IP is not the simple IP protocols, so that's why this uh, issue is another important issue. Mobile IP is most often found in wireless WAN, wide area network. I have written before that wireless. So wireless WAN environment, where the users need to carry their mobile devices across multiple LANs with different IP addresses. Now I want to show you one thing. Just say one source, one router, some mobile host. MH is mobile host. Router 2, router 3, and when source wants to transmit some information towards router 1, then router 1 may transmit its information towards router 2. Next to that, this router 2 may transmit the information towards mobile host. This is the architecture. Next to that, same thing, but mobile host now move from this particular location to this location. That means this is the mobility. It is not present under this router 2. It is present under this router 3. What happens? Source wants to transmit the information. That's why it may communicate with router 1. Router 1 may communicate with router 2, but when router 2 wants to transmit the information towards mobile host, then it is not so simple like previous thing. So what happened? This router 2 may transmit the information towards router 3, and router 3 then communicate with mobile host. In this way, this is the possibility of information transmission from source to mobile host. Okay, so this is the architecture. This is the most important communication way out for mobile IP. Now I want to tell you some common terminologies under this mobile IP. First thing, I want to tell you mobile node. It is the handheld communication device that the user can carry, simply like our cellular phone. Node which have some mobility and that have some ability to change its IP address also, but it cannot change its IP address. That is the main thing about mobile IP. Now, next thing, correspondent node. Correspondent node, it is a device on the internet communicating to the mobile node. This is simply a host with which mobile node is corresponding via some reliable protocol also. Home agent. What is agent? Any agent, when I will tell you, already I have shown in the previous figures, some routers. These are routers. But what kind of router it is? It is home router to which the mobile node actually connected. So, host in the home network of the mobile node. Next to that, this can register the location of the mobile node, tunnels IP packets to the care of address. Care of address. What is care of address? It is the temporary address used by the mobile node while it is moving away away from its home network. Again, I'm telling you, it is the temporary address used by the mobile node while it is moving away from the home network. So this is the care of address. Okay. Now, another important issue, foreign agent. It is the current network after some movement when one mobile host may be present under another router, then that is our foreign agent. Foreign agent is your another router like our router 3. So it is the current network to which the mobile node is visiting away from its home network, that is foreign network. And when I'm talking about the agent, then it is router under that foreign network to which the mobile node is currently connected. The packets from the home agent are sent to the foreign agent which delivers it to the mobile node. So foreign agent, it is the host, or better to say router, in the current foreign network of the mobile node. Okay, typically simply router forwards the tunneled packets. Already I told you. Care of address, as mentioned earlier, it is the temporary address. So address of the current tunnel endpoint for the mobile network at a foreign agent or mobile node. Another thing, actual location of the mobile node from an IP point of view, that also found using this care of address. Next issue related to node. Node means any host or router, anything. They are said to be the node. Nuance, a randomly chosen value or number different from the previous choices or previous values. Okay. Security parameter index, an index identifying a security context between a pair of nodes among the context available in the Mobile Security Association, Mobility Security Association, which is also known as MSA. MSA. Okay. Now, I want to show you few most important issue related to mobility. That's why I have shown this particular figure. Something it is also I can say vocabulary of our mobile IP. Now I have found one network here. Okay, and first thing, home network, permanent home of the mobile node. What I have written? I have written the first 3 bytes of IP address. There are 4 bytes, but I have written only first 3 bytes. And based on that, you are getting 24 masking bits for that. Okay, this is the permanent home address. When I can put dot for 40 dot some x, then that is the permanent home network router address for your mobile device. Next thing, home agent. This is the router. This is the network. This is the router. That's why I have shown using this particular symbol. Entity that will perform mobility functions on behalf of mobile when mobile is remote. Okay. Next to that, permanent address. Address in home network can always be used to reach mobile. And example, I want to take 128.119.40.186. This is the permanent address, okay, under home network. Next to that, I want to tell you wide area network, because already I have mentioned what is the main application in wireless WAN. So it may be connected over wireless WAN. Next to that, I am trying to show another network. That's why I have shown this one. Next to that, visited network. This is the foreign network concept. Network in which mobile node currently resides or moves. So the address is completely different from this one. 79.129.13 first 3 bytes that may be defined by 24 bits of masking address. Next to that, permanent address remains constant. Permanent address remains constant. That is not different. That is the IP address and fixed without changing the IP address. This is the first and fundamental concept of mobile IP. Next to that, care of address. Care of address in the visited network defined by same thing 79, it should be dot not comma 79.129.132, okay, not 13.2, it is 132. So something related to that is the care of address. Next to that, foreign agent. Foreign agent, that is another router. So foreign agent, that router may be used to transmit the information which can be collected from the home router, okay, or something simply like our previous figure, router 1 to router 2 and router 2 to router 3. This is something like our router 3. And next to that, this is correspondent, wants to communicate with the mobile device. That means corresponding node, I can say. Example of the network. This is home network. This is the foreign network. This is the router, foreign agent, and this is home router, home agent, physical home network of the mobile node, current physical network of the mobile node after movement. Okay, so this is the other devices connected with our mobile nodes, and this is the correspondent node. Last one is the correspondent node, and this one is the router that is connected with this corresponding node, and everything is connected over this internet. This is the main concept behind this mobile IP. In short, I want to mention the basic story behind the working strategy. Okay, next day I will tell you the main architecture and the basic protocols architecture and the communication way. But today I am going to tell you the working strategy. Correspondent node sends the data to the mobile node. Data packets contains corresponding node's address, okay, or source address, and home address. Home address means the destination address. Packets reaches to the home agent, but now mobile node is not present under this home network. It has moved towards this foreign network. Foreign agent sends the care of address to the home agent to which all the packets should be sent. Now a tunnel will be established between the home agent and foreign agent by the process of tunneling. What is tunneling? Tunneling establishes a virtual pipe for the packet transfer between entry point and the end point. It is the process of sending a packet via a tunnel, and it is achieved by a mechanism called encapsulation. Okay, so this is the basic thing about mobile IP.